Hey everyone, this is Sandeep Kaipu. I work in Broadcom as engineering manager. I'm focused on AI infrastructure and engineering leadership. Broadcom does multiple things. It provides as the AI infrastructure, networking infrastructure, and private AI cloud platforms for helping with the AI workloads. The Today I'll talk a bit about uh, 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 inference. We'll dig deeper into the fundamentals of inference, why we need inference at scale. Great talk so far. Emphasized this a lot, and that helps me here. And we'll discuss few strategies that we can use for scaling AI inference. Let's start with what is inference, just a step back and understand, right? Inference is a stage where we run models in production. That is where we put models to use, right? When a prompt comes into the model that is executing, the first step is tokenizing, convert to embeddings, and do the necessary pre-processing to execute. The model itself has weights to it, right? It is executing as weights that helps with the process of pre-filling. This is where it is a highly compute bound intensive task where a lot of computation of tensor vectors happen in the prefill stage and starts building what we call KV cache. And KV cache is as the brain that helps with the decode step later. Decode is the memory intensive step where the KV cache and the model weights for the LLM is used to generate the next token. That helps with the token in the sequence, helps in building the response. One token at a time, all the sequence of tokens are generated. Once we have their response computed, it goes through the step of detokenizing, and the response is given back into the query that is asked. Right? So this is at a fundamental level what an inference is, how the prompt goes and executes and comes out as response. It can scale up into multiple parallel workloads or whatnot based on the use cases, but this is the foundational level what happens. Right? Based on the execution context and where it executes, what is the latency requirements and everything, the types of inference may vary. You might have an online inference, which is generally the ChatGPT kind of world where we put a prompt and we expect the response as soon as possible. And the batch inference where large data sets are executed, they may not be critical, they may execute overnight or when the compute is idle and balance the load a bit and come out with a response when the compute is available. Streaming is where a large set of IoT kind of data sets that flow in to get the streaming inference required for a variety of use cases. When we move a bit into physical AI world, the inference cannot always happen on the cloud. It needs to move into the edge where the action is in place. Right? It can be an AV device, a robot, or anything where the inference is happening. And then when we understand what is inference and what are the types of inferences, we need to know who needs to worry about inference, right? It's not for everyone to worry about inference, but majority of customers organizations need to worry about inference, especially when someone is either building models, fine-tuning, deploying them, and executing the models, or companies who have a real-time use case, right? They are working at scale, users, millions of users. They need to own the problem end to end. It cannot be a siloed problem. I rely on the provider to take care of the inference. I need to own the problem end to end. That way you get the better user experience. Right? Or there could be a specialized requirement, be it security or running on an edge, as we've seen, or privacy, whatever the requirement might be. It cannot be on a public cloud. It needs to be on a data center, specific use case, and execute the inference in that scenario. So these are the scenarios where customers who own the workloads need to worry about inferencing, right? Yeah, like inference comes with multiple challenges. We have seen a lot of challenges in previous talks. It could be around how do we scale, how do we make it efficient, and with all the hardware availability challenges and power challenges, how do we manage them, right? How do we reliably, accurately generate the responses, right? How do you make sure it is secure? Where do you execute? How do you make it efficient? There are multiple challenges that one needs to take care of when we are owning an inference challenge, and it is important, right? Like if we saw in the previous session that like 70% of the cost is about inferencing than training. And training is 30%, and inference for an AI is 70% of the cost, because that is where model runs majority of the time serving user requests. Right? So then let's understand the scaling loss that came so far, and pushing the inference envelope a bit. Pre-training, where the model is all trained and ingested, but we are past that. But that scaling law, we are in post-training and test time reasoning. Majority of the models that we have right now are reasoning-based models. Like if we have three parameters that control the scaling law, that is like data, the infrastructure that we use, and the model that we have. Reasoning and the test time scaling, the phase that we are in, needs lot of tokens, lot of back and forth queries, reassessing if the response is right, reassessing if it is the right problem that we are solving is very important, and that is where test time reasoning comes in, and that put a lot of emphasis on tokens, and more tokens means more inferencing, right? That puts an essential importance on the reason for inferencing. For us to evaluate and understand, here are some of the key performance indicators that we can look into when we are evaluating the performance of the prompt responses. Some metrics to look into is like when is my first token coming up, how much time is it taking to generate the tokens, or what is the latency between the generation of the tokens, right? What is my tokens per second response rate, right? What is overall response to the query? How many queries am I able to perform in a given time? Right? These are the important metrics that one needs to measure for when we are looking at inference, and measure the inference scale. Let's look a bit in a layered approach for the strategies for scaling AI inference. At the bottommost layer, we'll discuss a bit about compute layer, and we can step a layer above on how the model is served and how can we make it efficient, and while building, what are the steps that one needs to take in terms of model optimizations that can make the inference faster, and also some of the solutions out there which provide inference as a service, and how to strategize about that. Start with compute. Generally, like this is where one can think about, like, yeah, GPU. We have CPU, just use GPU for inferencing. That is sufficient? No. We have lot of explosion of opportunities and possibilities in terms of compute that is out there. Assessing the right compute strategy for the requirement is very important. Is it GPUs that are sufficient for the workload? Then how do we distribute, and how do you make sure that can serve? or they're a specialized accelerator. They're now getting available through that majority hyperscalers build. They are available through various instances that they provide, that provide like that we can buy on and run the inference workloads on. Right? It could be Google TPUs or Inferentia from Amazon or Azure Mine. Right? And specialized ASIC processors, discuss Cerebras, it's a wafer scale compute, or SamNova, which does RDUs as a core of building inference focused workloads, or Grok, positron, multiple options that are available to handle and specialized in handling inference workloads. And the point here is understand what is the right compute platform that efficiently serve based on the requirements, and make the right decision. Then the layer about at a software layer, when we have the compute, networking, and storage available, how do you take that in and provide the inference serving? VLLM is a default standard that majority of customers use right now. It is an open source solution that is available out there. UC Berkeley developed, and later there are multiple variations of it right now that many companies have adopted. Especially Google Cloud recently announced LLMT, where building on VLLM, they're making it at a distributed scale. Hugging Face DGI is text generation inferencing is in a powerful alternate. Olama is heavily used, especially in a personal computing space. Nvidia is an enterprise solution that Nvidia provides, primarily focused on Nvidia GPUs. Now Nvidia is also working on a open source Nvidia Dynamo platform, especially for inferencing, given the scale at which inference is progressing. Nvidia Dynamo is evolving as a golden standard right now for inference serving at a distributed scale. Quickly, if we observe, like there are various, this is open source, we can look at the code and understand a bit deeper, but it has at the core is the prefill workers and the decode workers, the crux of inferencing that we see. And the solution is efficient planner based on availability of resources, and smart routing based on KV cache awareness, right? And how do we move the KV cache between the prefill and worker nodes so we can provide disaggregated serving, and how do we offload KV cache when not required, or when the usage is reduced. Right? So the flow from API serving to routing efficiently and executing is very important, and the open source platform is addressing it well and evolving to be a golden standard in that aspect. Like this is evolving to be a Kubernetes or Linux in the open source for distributed inferencing. If we move a step up in the stack and look fundamentally at a model level itself, there are multiple things at a model optimization, be it quantization, pruning, or distilling the knowledge, or compressing, where we can provide right amount of weight sharing, or low rank factorization, which helps with efficient execution of the model at runtime. Yeah, if we step further up and try to understand holistically, like this requires a lot of technical expertise. If we have to handle all the compute level, or serving level, or inference level, and the model optimization level. So there are multiple options that are starting up right now, which takes care of this problem holistically. And like if we see hyperscalers, they have efficient solutions providing inference as a service platforms, and also GPU clouds, they have multiple solutions, and private clouds providing NVIDIA NIMs and so forth for efficient serving of inferencing. And some notable things to look at here is the inferencing that is provided by like companies like Together AI, Fireworks AI. They're like focusing on how do we run efficiently fine-tuned models in production, right? How do we run like the machine learning models out in production. And any scale is an alternative as well. So understanding what are the end-to-end solutions that are available for inferencing and choosing the right option is a great solution out there. So with that, I want to reiterate what we discussed. We discussed about the inference as a whole, why we need inferencing, and what are some of the strategies that can help inferencing at scale. So, and to conclude here.